Hello everyone, welcome back to my YouTube channel. Today we'll be continuing a chapter of class 9 science 1, that is work and energy. So this is part 4 of the chapter. In part 3 we have discussed about energy and kinetic energy. So if you haven't watched the other parts, do watch it. The link is in description. So today we'll be starting with a topic with potential energy. So what is potential energy? As kinetic energy is related to motion of an object. It is related to moving object, but the potential energy is related to position of the object. As the word itself says potential, it means position. Okay, so as we know, an object can store energy due to its position. In this case of bow and an arrow, when the bow is drawn, it stores some amount of energy which is responsible for kinetic energy it gains when released. So as you can see here, when we stretch the bow, this is some amount of energy stored here. This is our potential energy. And when we release the bow, that energy is converted into kinetic energy. One more example. In case of spring, when it displaces from its equilibrium position, so this is its equilibrium position. It gains some amount of energy when we observe, in the form of stress we feel in our hands upon stretching it. So when this is its equilibrium position, so it has some energy, that is potential energy. And when we stretched it, that potential energy is converted into other form of energy that we feel in our hands upon stretching. So these are some examples of potential energy. Let us see more examples. So the definition of potential energy says that the energy stored in an object because of its specific state or the position of the object, it's called its potential energy. So like here one example is there. So ball has potential energy. Now the ball here, it has some potential energy because of its position. So when I drop the ball down, so when we drop the ball downwards, this potential energy is transformed into kinetic energy. So at a certain level, at a certain position, it has a potential energy. And when we drop it, the ball is now in motion. So this energy due to the motion of an object is called as kinetic energy. So here the potential energy is converted into kinetic energy. One more example, similarly we have already discussed here. So when we stretch the bow, here the bow has a potential energy. And when we released it, that energy is converted into kinetic energy. So I hope you understood the difference between potential energy and kinetic energy. Stone sitting on an edge of a cliff poses potential energy. This potential energy will be converted into kinetic energy if the stone fall down. Okay. One more example. Tree branches high up the tree have potential energy because they can fall to the ground. So these were some daily life examples of potential energy. Now here we have one question. Ajay and Atul have been asked to determine the potential energy of a ball of mass m kept on a table as shown in the figure. So this is Atul, this is Ajay, and this is a ball of mass m. Now here we have a table. Now from ground, the height of the ball from ground for Atul is h2 and for Ajay it is h1. So questions are, will they be different? Potential energies. Will the potential energy be different? What do you conclude from this? So what is the answer? Now these potential energies depends upon the mass of the object and height of the object, because it is due to position of the object. So for position, we require this height, from at which height the ball or the object is. Okay, so it mainly depends upon mass of the object and height of the object. So definitely the potential energy for Atul and Ajay will be different, as the height from the object is different from both. From Atul it is h2 and from Ajay it is h1. So the potential energy is a relative concept. It can be different for different person. The heights of the ball with respect to Ajay and Atul are different. So the potential energy with respect to them will be also different. Now we have a derivation or expression for potential energy that we'll be solving now. But Potential energy is dependent upon mass of the object and height of the object. And kinetic energy depends upon mass of the object and velocity of the object. As kinetic energy is for moving objects, so there the term velocity comes. But the potential energy is for the position of the object. So therefore, the term height has come. So this is the difference between kinetic energy and potential energy. Now we'll derive the expression for potential energy. So as you know, when we derive the expression, we first write the description of the derivation. So let us write a description. So as I said, the potential energy depends upon mass and the height. So first we'll write let m be the mass of the object. So first point is let m be the mass of the object. Okay. Now we want this object to carry at a height h above the surface. So when we are at a ground level, when we carry object from ground level, that is surface of the earth, above the surface of the earth at a certain height, we have to carry that object. Now, when we carry that object, what we required certain force. So that also we are going to mention. So my second point will be to carry the object at height h. From the surface of earth, force F, and force is nothing but mass into acceleration, that is equal to m. Now here we are carrying the object above the surface of the earth, that is against gravitational force. So here we will be using acceleration due to gravity, that is noted by small g. So your force will be equal to mg, right? So to carry the object at height h from the surface of the earth, force F is equal to mg has to be used against the gravitational force. Has to be used against the gravitational force. So this is the important point of the expression. So we have described about the mass of the object, height, and the force. Now we have to discuss about the work done. Now when we displace an object from one position to another position, there is a work done. We are applying force and we are displacing the object. So we will be discussing about the work done to displace the object. So therefore that my third point will be amount of work done can be calculated as follow. What is the formula for work done? Work done is equal to force into displacement. Now for force, we are going to write mg, and displacement here, it is height from surface of the earth at a certain height. So mg into h. So my work done is nothing but equal to mgh. Now when we have solved the derivation for expression of kinetic energy, there also we have found first work done, and we know that work done is nothing but equivalent to energy. So whatever amount of work is done, that amount of potential energy is stored in the object. So we can write, therefore, the potential energy stored in the object because of its displacement is potential energy equal to work done, that is equal to mgh. So whatever work is done, that is nothing but equivalent to potential energy stored in the object. So I hope you understood the expression for potential energy. So the formula for finding the potential energy is equal to mgh, where m is the mass of the object, h is the height of the object at which it is displaced, and g is the gravitational acceleration due to gravity. It is a constant, and the value of g is 9.8 meter per second square, or roughly you can take it as 10 meter per second square. Now we will solve some numericals based on kinetic energy as well as potential energy. Let us start solving the numericals. First one, a stone having a mass of 250 grams is falling from a height. How much kinetic energy does it have at the moment when its velocity is 2 meter per second? So whenever you solve the numerical, first thing is that you have to write the given part given the question. So here the given part is they have given the mass of the stone. So given is the mass which is equal to 250 grams. Okay. Next, they have given us the velocity 2 meter per second. Now, if you observe here, mass is given in grams, velocity is given in meter per second. So meter per second is a SI unit, but gram is a CGS unit. So we need to convert gram into SI unit. Okay. So what is the conversion here? Now, 1 kilogram is nothing but 1000 grams. So we need to find x kilogram is equal to 250 grams. So that x will be nothing but equal to 250 divided by 1000, cross multiplication, right? So our mass will be equal to 250 divided by 1000 kilograms. Sorry. We have to find kinetic energy. So to find kinetic energy. So what is the formula? Kinetic energy is nothing but half into mv square. So half into mass is 250 upon 1000 into velocity square, that is 2 square. This will be equal to, now here you have to do some calculations. So 25 ones are 25 fours are. This will be equal to 1 upon 2 into 1 upon 4 into 4. Square of 2 is 4. So again 4 and 4 will get cancelled. Your final answer will be equal to half. And the unit for kinetic energy is nothing but joules. So you can write it as 0.5 joules also or half joules also. So your kinetic energy will be equal to 0.5 joules. Okay. Let us go to the next question. 500 kg of water is stored in the overhead tank of 10-meter high building. Calculate the amount of potential energy stored in the water. So again, the given part here is mass of the object, that is water, 500 kg. Now this is in SI unit, kilogram, and height is given as 10 meter. And we have to find potential energy of the water. So our formula is potential energy is nothing but equal to mgh, right? So mass is 500. Now the value of g is constant. You can take it as 9.8 into height is 10. The value of g may not be given in the question. You have to remember it. The value of g is 9.8 meter per second square. So after solving this, what will get? 500 into 9.8 into 10 is 98. Now we have to solve this. 98 into 5. So 8, 5 it's a 40. 45 plus 4, 49. So it is 490. 490 and more 2 zeros are there. So this will be our answer. So potential energy here is nothing but 49,000 joules. 49,000 joules. Question number 3. Calculate a work done to take an object of mass 20 kg to height of 10 meter. G is equal to 9.8 meter per second square. Okay. Again, a similar type of question. So your mass is given as 20 kg, height is given 10 meter, and value of G is equal to 9.8 meter per second square. We have to calculate the work done. Now we know that work done to take an object at a certain height is also mgh, and that is nothing but potential energy of the object. Okay. So here I will write work done is nothing but equal to potential energy of the object, which is nothing but equal to mgh. Work done will be equal to mass is 20 kg into 9.8 into height is 10. This will be equal to 20 into 98. 98 into 2 will be 196 and 0. So this will be my answer. Is this answer correct? So here we have found the answer that it is 1960 joules. But if you read the question, work done to take an object. So we have taken an object at a certain height above the Earth's surface. So when we take an object above the Earth's surface, we are doing that thing against the gravitational force. So that is against the gravitational force. So here we'll indicate a negative sign to indicate that this work is done against the gravitational force. Okay. So here the answer will be minus 1960 joules. Okay. Here we will indicate that the work is done against the gravitational force. When we are calculating potential energy, that time no need to include that negative sign, because the potential is nothing but energy of an object stored with respect to its position. It is the definition itself says that it is due to its position. But when we are calculating work done, we have to indicate that the work done is against the gravity or with the gravity. So this work done is against the gravity, as you are taking the object from surface to at certain height. So here we are going to mention this negative sign. So I will mention here this negative sign indicates work done is against gravitational force. So question number 4. The velocity of a car increases from 54 km per hour to 72 km per hour. If mass of car is 1500 kg, find work done to increase the velocity. Now this is a certain different kind of sum. So first we'll write the given part. So your given part is mass of the car, that is 1500 kg. Then they have given us velocity. Two velocities are given. If you read the question, increases from 54 to 72. From 54 to 72. So 54 becomes the initial velocity, which is denoted by small u, that is 54 kilometer per hour. Now again, kilometer per hour is not a SI unit. Meter per second is our SI unit. So we need to convert this kilometer per hour into meter per second. And final velocity is given 72 kilometer per hour. Now what is the conversion factor for converting kilometer per hour into meter per second? Here we have to convert both the units, kilometer to meter, hour into seconds. So see, 1 kilometer is nothing but 1000 meter, and 1 hour is nothing but 3600 seconds. And we need to convert kilometer per hour, that is kilometer divided by, that means 1000 divided by 3600. If you simplify this, you will get 10 upon 36 meter per second. Again, if you simplify this, you will be getting 2 5s are 10 and 2 18s are 36. 5 by 18 meter per second. So this is the factor. So 1 kilometer per hour is equal to 5 by 18 meter per second. So here we have 54 kilometer per hour. That will be equal to 54 into 5 by 18 meter per second. So 54 kilometer per hour will be equal to 54 into 5 upon 18 meter per second. So 18 threes are 54. So 18 ones are 18 threes are 54. 5 threes are 15. So you are going to get here 15 meter per second. And 72 into 5 upon 18 meter per second. Again, if you simplify here, 18 fours are 72. 5 fours are 20. So 20 meter per second. So your initial velocity is 50 meter per second, final velocity is 20 meter per second, and the mass is 1500 kilogram. Now what we have to find? We have to find work done to increase the velocity. Work done to increase the velocity. That means how much work is done to increase the velocity of the car from 54 to 72. Initially the velocity was 54 and after some time it was 72. So to increase that velocity, how much work was done, that we have to calculate. So work done to increase the velocity that we have to find. Now here, this sum is different from other sums. So if we have to only calculate the work done, we'll write that work done is equivalent to energy, and we'll directly apply half mv square in case of kinetic energy. But here we have given two velocities and we have to calculate that work done when the velocity of the car increased from 54 to 72. So here work done to increase the velocity is nothing but equivalent to change in kinetic energy. So the kinetic energy has changed. When the speed was 54 km per hour, at that time the kinetic energy was different. And when the speed increased to 72, at that time the kinetic energy was different. So here the work done will be equivalent to change in kinetic energy. So here we have to calculate change in kinetic energy. Now what is change in kinetic energy? Change means final minus initial. So here the formula will be final kinetic energy minus initial kinetic energy. So a final kinetic energy is half m final velocity square. Initial kinetic energy is half m initial velocity square. So we'll just substitute the values, half, or you can take half and mass common and we'll get v square minus v square. That is equal to half into mass is 1500 in bracket v square. What is v? V is final velocity, that is 20. So square of 20 minus square of 15. First you have to solve the brackets. That is half into 1500. Now the square of 20 is 400 minus square of 15 is 225. That is equal to half into 1500 into 400 minus 225. That is equal to 175. Now if we divide it by 2, 2 ones are 2 sevens are 14, 2 fives are 10, 750. This will be equal to 750 into 175. And this we have to calculate here. So 175 into 75. 5 5s are 25. 7 are 35, 37. 8. 35. 52. And 12. 5. 12. 11. So 13125. 13125. And this 0 joules energy. Work done, sorry, joule. So this will be our answer. 1,31,250 joules. So I hope you understood how we have solved this sum. Let us move to the next sum. Question number 5. A body of 0.5 kg thrown upwards reaches a maximum height of 5 meter. Calculate the work done by force of gravity during this vertical displacement. So mass, that is equal to 0.5 kg. Then height 5 meters. Calculate the work done by the force of gravity during vertical displacement. Vertical displacement means from the ground till the height 5 meter. So the body is displaced from ground till the height 5 meter against gravitational force. So here we'll consider the value of G as minus 9.8 meter per second square. So here the minus indicates that the work done is against the gravitational force. So here we'll consider the value of G as negative. So work done will be equal to amount of potential energy stored, that is mgh. So your mass of the object is 0.5, that is half, into minus 9.8 into 5. If you solve this, you will get 2 ones are 2 fours are 8, 2 nines are 18. 4.9 into 5 and with a negative sign. So 49 into 5. 5 nines are 45. 5 fours are 20. 245. And one decimal is there. So 24.5 negative sign joule. So this will be your answer. Now let us solve question number 6. If the energy of ball falling from height of 10 meter is reduced by 40%, how high will it rebound? Now this question is also different from other questions. So let us understand what the question says. So the question says that at a particular energy, okay, at a particular energy, let's say x joules. So at this energy, the ball was falling from a height of 10 meters. Now I'm reducing this energy by 40%. So I'm reducing the x joule minus 40%. Then at what height the ball will rebound? That I have to find. So I hope you got the question. So the given part here is, first one is the initial height, h1. So initial height, that is h1, it is equal to 10 meter. So here for both the cases, the mass of the object is same. Also the gravitational acceleration is same. The only thing change is the height. For the first case, it is h1 and for the second case, it is h2. So here my mass and gravity are constant for case 1 as well as case 2. Only the change is in height. So what is the formula for potential energy? The formula for potential energy is mgh. So mg here is constant. For potential energy 1 as well as for potential energy 2, my formula will be mgh2. Only the height changes. Mg is constant. So I can say that potential energy is directly proportional to height. So potential energy 1 is directly proportional to height 1, and potential energy 2 is directly proportional to height 2, since m, that is mass, and g, that is gravitational acceleration, both are constant. Okay, so I hope you understood this story. So here I will write, so initial height h1 is equal to 10 meter. Okay, and then initial potential energy, that is potential energy 1, that is equal to mgh1. Next, final height, that is h2, that we have to find when the energy is reduced by 40%. That we have to find. And final potential energy, that is potential energy 2, is equal to mgh2. So my initial potential energy is mgh1 and final potential energy is mgh2. And we have to find here h2. Now, if you read the question carefully, reduced by 40%. reduced by 40% means initially there was some potential energy and 40% of that potential energy is reduced in the second case. So here I will write potential energy 2 is equal to potential energy 1 from first case, initial potential energy minus 40% of potential energy 1. So this is the meaning of the statement. The energy of the ball is reduced by 40%. Means initially it was potential energy 1 and it is reduced by 40% means minus 40%. How 40% of initial potential energy. So this can be written as potential energy 1 minus 40%. Percent means divided by 100. So 40 divided by 100 of potential energy 1 means multiplied by potential energy 1. So from here I can take potential energy 1 as common. So in bracket here it will be 1 minus 0.4. Right? 40 divided by 100 is 0.4, and if I take potential energy 1 as common from both the terms, I will get 1 minus 0.4. That is equal to potential energy 1 into 0.6. So finally I will get potential energy 2 is nothing but equal to 0.6 times potential energy 1. So this is a very, very important step of this solution. Next thing. Now here we will divide the two equations. Which are the two equations? This is our equation number 1 and this is equation number 2. Okay. So dividing 1 and 2, that is potential energy 1 divided by potential energy 2 is equal to mgh1 divided by mgh2. So potential energy 1 is, we don't know the value. So potential energy 1. What is potential energy 2? We have found here 0.6 times potential energy 1. So we'll write in place of potential energy 2, we'll write 0.6 potential energy 1. That is equal to mm and gg will get cancelled, h1 upon h2. So now I can write potential energy 1 and potential energy 1 will get cancelled. 1 upon 0.6 is equal to h1 is 10 divided by h2. So finally, h2 is equal to 10 into 0.6. Therefore, h2 is equal to 6 meters. So the ball will rebound at 6 meter height when the potential energy is reduced by 40%. So I hope you understood how we have solved this sum. This is a little bit difficult to understand. So we have to practice this particular sum and this type of sum. So this is the end of today's session. Today we learned about potential energy, expression of potential energy, and numericals based on kinetic energy and potential energy. So in that numericals, two numericals were different from others. That is question number 4 and question number 6. So do practice that 2 questions. If you like this video and found this interesting and helpful, do like, share, and subscribe our channel for more such videos. Thank you.